Hello and welcome to our update. Today is November the 30th. We are Team Plan B. What we'll update you on today is our thermal regulation for our nano satellite. We are on any objects that is sitting in a vacuum that has solar radiation coming in, and then on the other side dispersing that heat out into space. We need to figure out how to properly do that because our devices, our camera, our electrical system, if it goes too high, we know that if it goes to 125 degrees Celsius, it could cause damage to the system, and if it goes below 45 degrees Celsius, it could also damage the system. So it is imperative that we properly figure out a way of doing the thermal regulation for our nano satellite. So the first thing that we need is we need to make an environment, a test environment, a modeled environment, even before we step anything into the vacuum. We need something that will replicate the solar radiation. And as you can see, conditions aren't always great in Vancouver for doing that testing, so we have to figure out a way getting that environment, and so we can start our testing. What we have here is our model. Obviously this is a long ways away of having the ideal model, but right in the middle, this is our object that we will be doing our tests on. Right, this guy in here. On the top, this is where the heat from the solar radiation will come in, and then on the bottom, this is where we hope that the heat will radiate out of or disperse out. So right here, this object and the outside where the solar radiation is coming in is connected to a thermometer, right? So just speaking about the model, what will replicate the solar radiation, we'll use the ironing kit.
(200 degrees).
So solar radiation is the heat coming in. You'll see this is we're taking the difference of the temperatures. This 39.3 degrees Celsius is this object, is the temperature of this object, and the 51.52 degrees Celsius is the external plate where the solar radiation is coming in. And what we're doing is we're trying to have an ideal method of taking these measurements, right? There's numerous ways of doing it, but finding the difference in temperatures is our ideal approach. So as soon as so the next thing that we're using, we need a timer. This mini fridge timer that we got here, timed at 40 seconds. So as soon as the temperature drops to about 20, we'll go with 28 degrees.
29.
Okay. 29 degrees. We'll apply the heat, and the timer will be set for 40 seconds. Okay. The heat is off. So we will take this data based on the time. We'll take that the temperature, and we will record that in an Excel spreadsheet. And after that, after we have a vast amount of data, we could start analyzing how the object was behaving. So after we've got all these parameters, these measurements, we need to see how we can control this thermal process. And one thing that we're using is the Peltier element, and we have two of them in here, and basically it's a ceramic material where on one side there is heat, and on the another side there's a cooling, and off of that you could get you can generate electricity, or you could also switch the whole process by adding to one side. You could turn the cool to the hot area and the hot to the cool side, if that makes any sense. So instead of spending time developing a program, we could use this method this quick method to see how thermal regulation is done using the Peltier elements, and then we could go off and test it in vacuum condition. So this would be an approach that is not ideal, but this gives us an advantage in speed and of testing. So you could, if you don't know what a Peltier element, and my explanation wasn't good, you could do some research on it. But what we will do is, what we could do is we could connect these two wires, and what this will do, the one plate, the heat coming in onto the Peltier element will generate the electricity, and on the outside it'll be hot on the inside. So before this object there will be cooling, and the electricity generated from one plate will be used for the second plate on the other side of the object, and it will force a cooling on the far side of this object on the inside, while on the outside of the second Peltier element there will be the heat dispersion. So we're essentially, what we're doing is we will have these two plates, the object in between, and the heat coming in on the Peltier element will force the cooling here. The electricity generated from this plate will be used to generate cool on the inside and heat on the outside, keeping the object in between at a constant temperature. So to correct myself, the temperature on the object will not be constant. What we're trying to do is we're trying to see how the Peltier elements will act on the object. So what we will do now is we will bind these two wires and run a couple more tests. By couple I mean about 20. So let's just connect this. Let's go here. Okay. Let's fire up. Yeah, fire it up again. .3. Okay. So this is the answer that we got from all our experimentation. We did a quick rough draft here of this graph just to show you what's going on. This is objects with and without thermal regulation. The one here in the blue, this is without any thermal regulation. This is temperature in degrees Celsius. This is the heated plate that's mimicking the solar radiation coming in. This is the object. It's 29.18, and this is the heat radiating on the bottom side. So that's the means that we got here. This is with the proper using Peltier elements with the proper flow. And as you can see, the object in the middle is at 29.7, so it's a little bit hotter. And then this last one, this in the black here, in the black ink here, this is when we took, when we connected the Peltier elements red to red and black to black, and so this is the outcome of that. So it kind of shows that working without the Peltier element, it has a lower temperature on the object. So looking at this data, looking at it, we're thinking that, oh, this was a useless experiment, or a bunch of useless experiments. But no, this actually shows if we want to heat the object and keep it at a certain temperature. We just have to hit the on and off switch. So the program is, we're hoping it stays simple from what we saw here. So thanks again. This is our third addition to our to our measurements series. Thanks again for watching, tuning in. I hope this makes sense, and see you next week.